All right, let's take a look at Unit 4, Lesson 14. We're going to go ahead and skip the first piece of the lesson and move right into the second part, natural logarithm. So we're going to complete the table with equivalent equations. The first row is completed for you. So e to the power of 0 is equal to 1. So remember, when we write this in logarithmic form, that would basically be log base e of 1 equals 0. Notice over here, this ln is in the place of log base e. That's called the natural log, right? That log base e is called the natural log or logarithm. And we just write it with an ln, so you don't have to do log base e. It's just ln. So log base e is the same thing as ln, which we call the natural log, right? And you can think of log natural, ln. Okay, so for b, we know that e to the first is equal to e. So that means the natural log of e is 1. All right, for c, the natural log of 1 over e is equal to e to the negative 1. Oh, no, that's not right. Sorry, it's the negative 1. It's the exponent. Lost my train of thought there for a second. All right, so again, this is the natural log piece. And then this is what you're taking that natural log of. And then the exponent is what that equals. Okay? All right, so if the natural log of 1 over e squared is equal to negative 2, that means e to the negative 2 is equal to 1 over e squared. E to the x is equal to 10. So the natural log of 10 equals x. And that's super helpful because you can plug that one into a calculator to get an approximate value. All right, number 2, solve each equation by expressing the solution using ln notation. Then find the approximate value of the solution using the ln button on the calculator. And so we have our Desmos calculator here. All right, so we have natural log of 20 equals m. So m is approximately, and I'm going to go to my functions here. My natural log is here, and I'm just going to type in 20. And so I get about 2.996. All right. I could just modify that one for the next problem, but I'm going to show you something else. All right, so e to the n equals 30. So the natural log of 30 is equal to n. So n is approximately, and I want to show you that you can type in ln and it automatically turns that into the natural log. So you don't actually have to go find that function. You could just type in the letters ln and it will automatically change that for you. And then we're taking the natural log of 30. So that's 3.401. Again, this is an approximation. All right, so now that we've seen the two ways of doing that, we'll just use that one. So e to the, no, sorry, what am I doing? We're turning this into natural log. So the natural log of 7.5 is equal to p. So p is approximately, and I'm going to change that 30 into 7.5, so I don't have to retype it, and we get 2.015. All right, let's take a look at the next piece, solving exponential equations. So we are going to solve each of these equations without using a calculator. You might need to express some of them with log notation, and that's totally fine. Since we're not using the calculator, I'm going to get rid of that and make these a little bit bigger. Okay, so 10 to the x is equal to 10,000. Well, how many zeros are there? You can look at that as log base 10 of x, or I'm sorry, of 10,000 equals x. If you want to, log base 10 of 10,000 is equal to x. You don't have to do that. Just look at, okay, 10 to what power is 10,000, so x is going to equal 4. Again, you don't have to do this piece. It's not necessary. All right, number 2, 5 times 10 to the x is equal to 500. So the first thing I would do is divide both sides by 5. So then I have 10 to the x is equal to 100, and that one is pretty easy, x equals 2. All right, for the next one, I am going to change that 10 to the x plus 3 and let that equal 10 to the 4th, because now I know that x plus 3 equals 4. And so I can just solve that equation. So x equals 1. All right, and then I'm going to do the same thing with number 4. I'm going to change that 10 to the 2x. I'm going to change that 10,000 to 10 to the 4th. So then I know that 2x is equal to 4, so x must be 2 because I'm going to divide both sides by 2. Those kinds of problems you might see on the SAT. They're fairly common to be put on there. All right, number 5, 315 cannot be changed to 10 to some power. Not exactly anyway. So we're going to convert this one to a log. So it's log base 10 of 315 is equal to x. And that's really all you have to do, right? You're not solving anything else. You're not finding an approximate value. All right, so then we're going to do something similar here with number 6. The first thing I'm going to do again is divide by 2. So 10 to the x is equal to 400, and then I'm going to put it into logarithmic form. So log base 10 of 400 is equal to x. That's a lot easier. All right. So for number 7, I am going to do log base 10 of 4,000 is equal to 1.2x, and then I need to get rid of my 1.2 because I need my x to be by itself. So I'm just going to divide both sides by 1.2. So my answer is x equals log base 10 of 4,000 divided by 1.2. All right, number 8. Again, I'm going to divide by 7. Just to get my 10 to the 1/2 x by itself. So I have 10 to the 0.5x is equal to 10. And then I know that this is really 10 to the power of 1. So 0.5x is equal to 1. And then I'm going to divide both sides by 0.5 or 1/2. And actually, I'm going to change that to a fraction. Well, here, we'll just do it this way. So x equals 1 divided by 1/2. And remember, if you're dividing by 1/2, you're really multiplying by 2. So x equals 1 times 2, which is 2. All right, number 9, I'm going to divide both sides by 2. So e to the x is equal to 8. So then I know the natural log, because that's log base e, of 8 is equal to x. And then number 10, again, divide by 10 on both sides. So e to the 3x is equal to 25. So the natural log of 25 is equal to 3x, and then I need to divide both sides by 3. So x equals natural log of 25 all divided by 3. And that is how you can solve equations using exponential equations. And then if you wish, there is a summary down here if you want to see a little bit more, a few more examples.